Hey guys, welcome to Differential Equations, where I'm going to attempt to show an example from lesson 22, variation of parameters. Maybe you saw the pictures showing how we created these formulas, but if not, then really we're just looking at this big takeaway. So we are solving non-homogeneous linear equations with constant coefficients. And so we know it's non-homogeneous because it's not equal to 0. And last time we talked about it through the method of undetermined coefficients, but that had a limitation that it had to be in a particular form. And so this method called variation of parameters kind of fixes that weakness. And so there's a long, process to get to these formulas, but really, pretty much, these were the formulas we got in the pictures. And so, how do we do this? Well, we find our complementary function, and then we use those in order to find the Wronskian. And then from the Wronskian, we can use formulas. But notice that these give us the derivatives, and so then we're going to have to integrate in order to find the actual u1 and u2, and then we're going to multiply u1 and u2 by the answers we got from our complementary function, and that'll get us our particular solution. And then we're going to add our complementary function and our particular solution together to get our general equation. So let's go ahead and try one. Let's see if I can lay this down. All right. So the example that I want to try today is, try again. Y double prime plus y equals secant theta tangent theta. Okay, so let's note a few things. The coefficient here is 1, so a2 is 1. And then our, it's theta this time. Our q of x is going to be secant theta tangent theta. Okay, so the next thing we have to do is we have to find our characteristic equation. In order to find our characteristic equation, we're going to solve this equation where it's equal to 0 instead of secant tangent. And in order to do that, we have to find our auxiliary equation. So we've got m squared plus 1 equals 0, and that's the function, our quadratic function we're going to solve. When we solve that, we get m is plus or minus I. Okay, so that means that our two solutions, one solution is going to be cosine theta, or sine theta, and the other one's going to be sine theta. The order really doesn't matter. But we're going to use those in order to find our particular solution. Realize that this means that our complementary function is c1 cosine theta plus c2 sine theta. Okay, well, let's get on to our particular solution. So the first thing we have to do is find our Wronskian. Our Wronskian is going to be found from the matrix created by our complementary solutions and then the derivative of those. So the derivative of cosine is negative sine, and the derivative of sine is positive cosine. And when we find the determinant of this, cosine times cosine is cosine squared, minus negative sine times sine is a negative sine squared. And so our Wronskian is just 1, and that makes it kind of easy, kind of nice. So now let's figure out what these u things are. So now u prime is going to be a negative y sub 2 q of x, or theta in this case, a sub 2 times our Wronskian. So we see that u sub 2 is sine, so we have a negative sine theta. Even further down, q of x, or q of theta in our case, times secant theta tangent theta over our coefficient we said was 1, our leading coefficient is 1, and our Wronskian we said is also 1. Remember that secant is 1 over cosine. So this ends up being a negative tangent squared theta. Okay, so but remember we have to, this is still a derivative, so let's integrate this. In order to figure out what u is just by itself. So negative tangent squared theta, you can stick this into your calculator, you can look at tables. When you do, you find out that this is theta minus tangent theta. Okay, so that's the first one. Let's find the second one. u2 is a positive u1 q of x a sub 2 times the Wronskian. So our first one we said was cosine. Our q of x is the same as before. The rest is actually the same as before. So secant tangent over 1 times 1. So again, secant is 1 over cosine. So this one's just tangent theta. And again, we're going to have to integrate this in order to get not the derivative. So let's integrate this in terms of theta. So that means we're integrating tangent. And again, stick it in your calculator, look at a table of integrals. We end up getting that u sub 2 is the negative natural log cosine of theta. So we're not quite there. We're getting close though. So that means that our particular solution is u1 times y1 plus u2 times y2. So u1 we said was theta minus tangent of theta. y1 we said was cosine. Plus u2 we said was a negative natural log of the absolute value of cosine. y2 we said was sine theta. Let's clean this up just a little bit. Let's go ahead and distribute this in. So I've got theta cosine of theta. Cosine times tangent. Tangent, remember, is sine over cosine. So if I take that times cosine, I get just sine left over. And this other one really can't change a whole lot. So let's just rewrite that. Okay, so there's our particular solution. Whew. Okay, what about our general solution? Remember, our general solution is our particular solution, or our complementary solution, plus our particular solution. So we've now got C1 cosine theta plus C2 sine theta plus our particular solution plus theta cosine theta minus sine theta minus natural log of cosine theta sine theta. Okay, and that's pretty good, other than, notice we've got sine theta, and so those can combine. And so probably the answer you would see in the back of the book, or, to be perfectly simple, would just combine those. And of course that will now be different than that one. I cannot combine my cosine because this theta is changing. And so it can't combine into this constant. And that is going to be our answer. hopefully this helped, guys. Just as a note, if you go and you try to find other videos, there are kind of 2, maybe 3 ways of doing this. One is use a system of equations, and we did do that in order to get our formulas. The other one is kind of a Wronskian method, and that's probably closer to what we did, but we took that even a step further and just found these formulas for u sub 1 prime and u sub 2 prime. And so if you're going to go find other videos, I would kind of encourage you to go find ones that have the Wronskian method, because it's actually closer to what we're doing. But hopefully this helped. Let me know if I can help in other ways. Bye.